I hope you see the presentation, right?
Yes, yes, I believe you can also.
Okay, I have recorded presentation, so I let the presentation flows, and then I'll be available for the question and discussions.
Okay.
So, yeah.
Okay, thank you.
So let's start.
I don't think we can hear what you're saying.
Yes.
In your presentation, it's not audible to me. I don't know if other people can hear it.
Yeah, no, there's no sound.
Yeah, there's no sound.
There's no sound.
Yes.
Faji, there is an option when you share your screen that you have to tick the option share computer audio when you share your screen, and it will work it.
Okay, share computer audio. You hear the presentation now? It's audio.
Not yet.
No,
Not yet.
unfortunately not.
Fajili, try to take your headphone and do the same thing, please. Thank you.
Okay, participants can now see my screen.
Yes, we can see it.
How would sound?
No.
Do you remember what you said? Maybe you just need to talk over your screen.
Okay, let me let me present normal.
I think so.
Yes, to save on time.
Yeah. Okay, I hope you see my screen now. Okay, my name is Fadili Mustafa Malesa from the School of Aquatic Science and Fishery Technology of the University of Dar es Salaam. I'll be presenting on spatial temporal variation of zooplankton and fish larvae community structure in seagrass areas of Tanga coastal waters in Tanzania. And in this study, I'm collaborating with Margaret Kwalianga from the Institute of Marine Science and Barnabas Tarimo, a PhD student from Stockholm University in Sweden. So from the first three pictures that we see, these are dominant zooplankton genera that were found throughout the sampling periods. And most of them, these are the copepods that we are able to identify. And the three pictures that you see, these are the common fish larvae that we are found throughout the sampling periods. And they are genera belong in Labridae, Scaridae, and Ebulidae. Most of fishes' productivity originated from coastal habitats and mainly from coral reef, seagrass, and mangroves. And this is due to higher availability of food resources and the structural complexity of these coastal habitats, and then make a number of organisms to survive in these habitats. But there is a strong and growing evidence that these coastal ecosystems are declining, and mainly due to anthropogenic stress and natural disasters. And there is a spirit of these coastal habitats make them vulnerable to degradation, especially illegal fishing activities that have been conducted in different coastal areas. And then this affects the recruitment of fish larvae and then overall fisheries productivity. And in this study, we focus mainly on the seagrass habitats, and it's due to the functions structure of these habitats. The studies of zooplankton and fish life in different seagrass areas, whether these seagrass are degraded or healthy, we investigate the structure complexity and the ecological function of these habitats if they're able to support if they're degraded. So in this study, it's very important in predicting the sustainability of fishery resources under changing environmental conditions. The study was undertaken in the coast of Tanga, Tanzania. Is the map of Tanzania showing the coast of Tanga where the study was undertaken. And the study was divided into two parts, where based on the status of seagrass, whether degraded or healthy. And in the degraded side, these are the sites which are close to the coast first and have low percentage of seagrass cover and experience high intensity of degradation, mainly from fisher stocks. Using of beach seining, using of ring nets and trampling affect the structure complexity of the seagrass. And these sites we call as degraded. And another category is based on intensity as well of the degradation. We call it the health site. The health site, these are the site first, which are far from the coast and experience little influence from fisher stocks. And then the study was conducted in 2 seasons, in southeast monsoon season and northeast monsoon season. And in southeast monsoon season, this is the season is experiencing high wind up to 9 meters per second speed and low temperatures. Also, there's a little rainfall during the southeast monsoon. Compared to northeast monsoon, there's a moderate wind speed, which is up to 5 meters per second, and it's catalyzed with the short rains and high temperatures. The collection of zooplankton and the fish larvae we are collected based on status of seagrass, as I say. So the collection of zooplankton and fish larvae were collected using the mean size of 150 micrometer for the zooplankton and 500 micrometer for fish larvae. And the other physiochemical variables, temperature, dissolved oxygen, pH, and the other physiochemical parameters, such as nutrients and COFR, were recorded in laboratories. And through cluster, in data analysis, the community structure of fish larvae and the zooplankton were analyzed using primer 6, whereby the constraint additional analysis were revealed to see the sequence differences of this community structure in different habitat conditions and season-wise. Results and discussions. There was efficacy differences between these physiochemical variables between season and subsite-wise, and the high growth R concentrations were recorded during southeast monsoon season, and this is due to the strong wind affect the water agitations in local areas, and this lead to local upwelling that bring a lot of nutrients from bottom oceans, and then make a lot of nutrients in the surface act as ingredients of phytoplankton to grow, and then this result to higher growth R concentration during southeast monsoon than northeast monsoon. And this is revealed by different studies, studies that were conducted in the Western Indian Ocean, experienced high growth R concentration during southeast monsoon than northeast monsoon. But based on status of seagrass, the growth R concentrations were observed below in degraded sites in brown color bars than southeast monsoon. In terms of nutrient concentration, especially silica, phosphate, and nitrates, were high as well during the southeast monsoon than northeast monsoon, as explained, is maybe due to upwelling, local upwelling that occur along the coast of Tanga in Tanzania. In terms of zooplankton density per taxa, it has been observed that there is higher zooplankton density in degraded site than health sites. And this is due to a higher availability of food resources in degraded site, as is revealed by the higher aqua concentrations in the last slide that we see. So the high availability of aqua concentration, which might attribute the availability of phytoplankton, which are the source of food for the zooplankton in degraded site and health sites. But in seasonal wise as well, there's higher zooplankton density during the southeast monsoon than northeast monsoon, as revealed by high availability of nutrients and phytoplankton source of food for the higher number of organisms. And through clustering spatial analysis, it has been revealed that there are many zooplankton genera that were found throughout the sampling period and in all subsites based on status of seagrass. Mainly acalanoids, cephalopods, herpetoids, and the other zooplankton genera. This contributes significantly to the availability of food of fish larvae, to fish larvae, and then to higher level of organism, despite of different status of the seagrass that we observed. As well, on diversity indices, we have been observed there's higher diversity indices during the southeast monsoon than northeast monsoon, and the high diversity indices as well we observed in degraded site than health sites. In fish larvae density, we have observed that the higher fish larvae density were observed in health sites than degraded sites. So here, ecological function of seagrass was revealed by the health of seagrass. And in seasonal wise, higher fish larvae density were observed during the southeast monsoon than northeast monsoon. And this is due availability of food of phytoplankton, zooplankton as the main source of food to zooplankton. And through clustering analysis, it has been observed that most of the common consumed fish families were found in health sites than the degraded sites. So here you can find the implication that when we degrade the seagrass health, it means that we alter the ecological function of seagrass to support fish larvae. So those fish families that depend completely on the seagrass habitats, when the functionality reduced, it means that we could lose these species which are the most consumed in coastal areas. So in conclusion, there is a clear seasonal heterogeneity of zooplankton and fish larvae influenced by the combination of factors, including hydrographic and biological factors. And you have been observed that the zooplankton, you can't link directly to the status of seagrass, but for the fish larvae, you can link directly in the status of seagrass, whereby we saw that higher abundance of fish larvae were observed in health seagrass site than degraded seagrass sites. Therefore, the conservation strategies of this coastal habitat should take account several factors to ensure the sustainability of fishery resources and the productivity in the future. The study was supported by the Western Indian Ocean Marine Science Association and the Marine and Coastal Science for Management for the MASMA programs. And it was the collaboration between Kenya Marine and Fishery Research Institute in Kenya, Institute of Marine Science of the University of Dar es Salaam, Tanzania, and Stockholm University in Sweden. Thank you very much for listening.
Thank you very much, Fadhili, for that very insightful presentation. But because of time, I think people can send their questions to your private chat, if that's okay. Either comments or questions, so that we might move on to the next presenter. But thank you for that presentation. So Frank Mirobo, if you're ready, kindly, you can start your presentation. Frank?
It's a recording, so.
Oh, okay.
A very good day to you all. I'm Frank Mirobo. I'll be taking you through the topic, the impact of the shark liver oil trade on the conservation and management of threatened shark species in Zanzibar, Tanzania. This is my master's work, and it was provided by Professor Bebe from Addis Ababa University and Dr. Saleh Yahya from the Institute of Marine Science. So this work will cover the following content, and starting with, so for decades, shark product, they have been one of the most utilized products into the fisheries ecosystem. And shark, they can be extracted for a number of activities for their fins, skin, jaws, teeth, and all that. So fin trade has been one of the most variable trade when it comes for the sharks, but it also a leading for the case of exploitation. And there is a bulk information when it comes for the science of this shark species, the diversity, ecology, and how these shark products, they can be used as a good source for medicine and for curious state. But there are so much focus and pressure on the fin trade as it is one of the most impactful trade. And there is less concern when it comes to the shark liver oil trade on the effect it has on the conservation and management of threatened shark species in Zanzibar, Tanzania. So therefore, this work basically aimed to answer the following questions as seen into my slide. It aimed basically to address one, as the general one, to examine the impact of the shark liver oil trade on the conservation and management of threatened shark species in Zanzibar, Tanzania, but specifically to determine the major species that are prone to this kind of trade. Number two was to determine which species they are good when it comes for the quality and quantity of the oil in human consumption and wooden boat maintenance. But also it aimed to determine how effective the burning of the shark products in Zanzibar was towards the conservation and management of the threatened shark species in Zanzibar, Tanzania. This work was carried out in Zanzibar, especially to Unguja Island, and it covers 4 villages as seen into my slide. So to the side of the data, to objective number 1, we used field observation questionnaires and focus group discussion, and the analysis was done by SPSS and Microsoft Excel. Objective number 2A, that is the quality of the shark liver oil trade. We did shark liver sampling, doing the dissection of the shark liver as seen from the figure. And also we were able to use the acidic values and the viscosity to be able to determine the chemical content and how that oil is in respect to human users and wooden boat maintenance. Coming to the quantity, we also did the sampling, focus group discussion questionnaire, and key informative interview. But also we also did a length weight relationship to be able to determine if there is any significant relationship into the production of the shark liver oil trade. The analysis was done as it has been seen into the slide. So objective number 3, that is the effectiveness of banning of the shark liver oil trade. We did key informative interview, and qualitative landing sites was also obtained as a secondary data. And the analysis was done using the analysis of variances. So coming up to the results, this work it has been able to determine or to identify tiger shark, giant guitarfish, short macrofin, bull shark, and cyclefin lemon shark as one of the most prone shark species that are prone to shark liver oil trade in Zanzibar. And during the conduction of this study, we obtained 27 specimens of 5 different species, which they were basically in large in size. And longline has been one of the most used gear to obtain this kind of species, which this argument, it is in line with the argument made by Barrowcraft in 2017, but also the wider distribution of this species, it is now most of the species, they are now being distributed to the southern side of the island, that is Kizimkazi village, unlike to the argument made by Schaeffer in 2004, whereby most of the species they were seen to be to the northern side of the island. So basically, these kind of species, they have been also exploited, as I mentioned before, but one of the species which is very rare to be seen now, it is the giant guitar fish, where it is very rare to be seen, where it takes approximately 1 to 8 months to be able to catch this kind of species, where these findings, they are in contrast with the argument made by Schaeffer in 2004, whereby he said most of the sawfish are the ones who are not really seen into the side of this island. And these species, they are believed to be not seen due to the fact there is invasion of the foreign fishing vessels, poor fishing method, and all that. So coming to objective number 2, basically the sample for tiger shark and cyclefin lemon shark has been the only shark liver oil that meets the standard for human consumption, unlike to the other side, whereby only the sample for giant guitarfish, it was the only sample which met the standard to be used for wooden boat maintenance. So basically, to the other side of the quantity now, only this study has been able to determine that the tiger shark is the most shark species that produce higher amount of the shark liver oil, and there is high significant relationship between the length and the weight of the liver in relation to the production of the shark liver oil trade. So basically, the market of this liver, it is found within the villages, and basically the most use of this oil is for vessel maintenance, although there are also another alternative as seen into my slide. Coming to objective number 3, basically we aimed to determine the landing of the shark, but we were unable to get it, but we managed to get the landing for all the Erasmus branch. This is due to the fact that the data recording for the ministry, it groups all the species under Erasmus branch in one category. So mostly Erasmus branch, they have been seen to shoot up as the time goes, as seen into my slide. And finally, the burning of this product, it has been the verbal burning. There is no any regulation which has been placed to make sure there are a follow-up of burning of this trade. Therefore, this study strongly recommends, to the case of management and conservation, the government officers to be accountable when it comes to the monitoring. Conservation strategic plan needs to be there that involve the fishing community and all stakeholders, but proper data recording we need to differentiate the group of elasmobranch from shark rays and all other group. For the future studies, we strongly recommend the same studies to be carried out to the other part of the island, but also the acidic value has been used as the means to determine the quality of the shark liver. So we also encourage further studies to be done to the other values, also the peroxide and moisture content of that oil. But also we encourage the seasonal variation of this liver into the production of the shark liver oil trade. I would like to express my deepest gratitude to my supervisors, my data collection team, and my funders, as seen from this slide, and my host. Thank you so much. Now I can be able to take questions if there are questions. Thank you so much.
Thank you. Thank you very much, Frank, for that presentation on the impact of shark liver oil on the trade on conservation. Anyone with some questions? Kindly. We can take very short questions. We have like some 4 minutes with us. Any questions?
Yes.
Yes,
Hello?
Frida. Yes,
Yes.
Frida.
Thank you, Mirobo, for the presentation. I was listening through, and I'm comparing with the Kenyan case of such things that are happening around the shark market. And my worry is that I was waiting for your conclusion, but I did not see a conclusion. Could you please tell us what your conclusion was? Because I see a conclusion that is actually telling us to go, that it was just a baseline study. So what was your conclusion from this study? We've seen the recommendations, but I need to see your conclusion. Thank you.
Okay, can everybody hear me?
Yes,
Yes.
yes, we can hear you.
Yes, thank you so much, Frida, for that question. So basically, the conclusion about this work, it is apart from the shark fin trade, which is one of the most impactful trade, but also like the management plus the government plus the stakeholders need also to think of the other kind of trade that also impacts the management and the conservation of this threatened species along the Wheel region. This means that like we need also to place our focus and pressure on the other trade, not only the fin trade, which is most impactful, but also this other kind of a trade. One of it is the shark liver oil trade. So like it means most of the people, they have ignored it and they assume it doesn't affect the conservation and management of this species. So it is more of the policy makers to also see the other side, like not only the fin trade, but also there is also other trade going on, which also impacts the conservation of the shark in the Whale region. Thank you so much.
Thank you, Frank.
Okay, thank you, Frank, for your insights. I can see there are more questions and more remarks on the chat session. So I believe you can go through that and answer some of the questions. So I'd like us to go to the next participant, Aina from Madagascar, who will take us through the development of a guide on best practices in fisheries management planning. Yeah, kindly take us through. Thank you.
Thank you, Chair, for giving me the floor. Do you see my presentation?
Yes, we can see your presentation. Just have it in presentation mode. Yes.
Okay.
Yes.
Okay, so first of all, greeting from Madagascar. My name is Niaina Janarville. I am the Marine Policy Officer for the USAID's High-Tau program implemented in Madagascar now. So it's an honor and a pleasure to present you on behalf of the Ministry of Fisheries and the Blue Economy, the development of this best practices guide for fisheries management plans. We call it with this French acronym PAP in Madagascar. So first, let me give you a little bit of overview of Madagascar context. Madagascar is the fourth largest island in the world, with its easy the twice of the surface of the terrestrial territory. Madagascar is a developing country with over 25 million inhabitants, of whom 10% live in coastal areas and depend on small-scale subsistence and artisanal fisheries for food. So it represents about 65% of annual national catches. In terms of biodiversity, Madagascar is one of the world's marine biodiversity hotspots. Among others, we have the second largest coral reef in the world, have about 20% of African mangroves, and have many other important ecosystems such as seagrass beds and islets. In terms of challenges of the management of marine ecosystem and fisheries in Madagascar, we have an adverse governance conditions. We have a weak science-based marine management decision-making, a lack of MSP while overlapping established sectoral activities. The government is overwhelmed by the cost of conservation. We have this open access to the sea that creates many challenges on managing the marine resources, and conflict between existing management measures such as marine protected area and management transfers. That leads to a disadvantaged coastal population. So poverty, coastal community are isolated. There is a lack of management capacity and weakness of customary law. And we have a steep population growth while they have unmet needs for family planning services. In front of all of that, we have an unsustainable exploitation of the resources that can be seen as overfishing, the use of destructive fishing practices. We have a conflictual overlapping fishing zones. The mangrove and many other challenges as the deforestation of mangroves, mining, and the negative externalities of land-based activities such as pollution and erosions. In front of that, we have, let me introduce a little bit about the project I worked for now. So it is called High-Tau, which means literally know-how. So it is a 5-year project that has as a main objective as to enhance and reinforce local level outcomes by creating and enabling an empowering environment. As a main pillars, we have sound policies and allow capable stakeholders. And the outcome is climate resilient livelihoods and biodiversity conservation. Specifically on coastal zone management, High-Tau started with the documentation of coastal and marine tenure rights and contributing to the improvement of the governance of coastal and marine resources. So as main activities, we have this PAP guide development and many other relevant, such as the development of the mangrove strategy and some capacity developments on fishery management. So why fisheries management plan guide? So it was developed in 2019, and there we have an ideal and open regulatory and policy framework with the new fisheries code. And we are in a good timing as well to capitalize over 5 years of experience in the implementation of PAP in Madagascar. About the concept of this PAP guide, so it capitalizes on the assessment of existing PAPs based on Malagasy experience and international guidelines. We have been considered below the 4 elements assessments. So the fishery management plan development and validation process, the governance framework, technical contents, and implementation. As international guidelines, we rely on the Code of Conduct for Responsible Fisheries and the voluntary guidelines for securing sustainable small-scale fisheries as well, developed by FAO. The guide is practical and easy to use, which is endorsed by the ministry in charge of fisheries and involve all of the relevant stakeholders. So you can see here the preamble signed by the minister himself to demonstrate this endorsement. Going into deep in this process of elaborating the fishery management plans. So it is a 12-step process. This is in French, but it has 3 sections. First is incubation and scoping, going through 3 steps. First step is rationale and scope of the plan. The second one is to define the participatory and the collaborative approach. That means all of the stakeholder engagement, plan development, and stakeholder mapping. After that, we have surveys for a global diagnosis of fisheries. And after, we go to the second section of the process, which is the elaboration. So the launch of and information workshops, formalization and the publication of the PAP framework document. We have a community technical workshop per management unit. So this is kind of from there, we are gonna conduct all of this consultation and development of this management units. After that, there is a cyclical consultation process, followed by the first detailed draft implementation plan per management unit. Ninth is social impact studies. And the 10th step is the first meeting of the steering committee and validation of the PAP content. And finally, we have the last section about implementation. So it is the publication of the PAP document, communication and outreach campaigns, and finally the establishment of governance and implementation structures and management tools. Specifically on the approaches to the effective implementation of the PAP, we go through the regulation of fishing activities. So to be succinct, we are gonna repartitioning the PAP area into management units, as I said before. We need to structure the fishing communities at all levels. So that at the smallest, as a group of fishermen, and after unions, federation, and consultation platforms at the regional levels. We go through the professionalization as well of fishermen's profession. So the use of professional cards, registration of fishing boats, and marking of fishing gears. and finally going through capacity development to improve their capacity on managing fisheries in their management unit and area. And finally, in terms of perspective, the PAP guide is currently used for the development of all new fishery management plans in Madagascar. So if you can see on the map, the red one are the existing PAPs, already existing PAPs. We have 4. And in a blue one, the under development fishery management plan using this new guides. So 3 ongoing, and the final perspective is to cover the coastal area of Madagascar with a fishery management plan. So the PAP guide is open to improvements and will be updated with new good practices and lessons learned in 2023. And the PAP is now available in a booklet of A5 format and available as well online on relevant portal and websites. So that's all for my presentation. Just to acknowledge my colleagues from the University of Rhode Island here, Sarah Gaines and Karen Kent. And thank you for this opportunity to present this. And that's all for my presentation. Okay.
Thank you. Thank you very much, Niaina, for your presentation. I think we can take 1 or 2 very short questions before we break for lunch. Any questions? Any comments, remarks? Thank you, Aina, for that wonderful presentation. So that marks the end of our second session. Been nice hearing from all this presentation on fisheries and sustainable livelihoods. And I think we can take a break and meet in a few minutes for a post session. Thank you.
Thanks, Stephanie. And thank you all of our speakers. That was great. It was really interesting. And because we had such a popular topic, there will be more discussions about sustainable fisheries tomorrow. But now, yeah, we can move it. There's a break, and then after the break, we'll move into the poster sessions. I've put the links in the chat.
Thank you, Shannon.